Beneath 4 kilometers of Antarctic ice, in total isolation for 34 million years, ancient lakes teem with microbial life that defies every rule we thought we knew about survival. Rivers flow uphill, volcanoes simmer unseen, and locked inside the bedrock lie geological formations whose value could redraw the map of global power. From above it looks like endless white nothing. It is not. Beneath the surface pulse hidden drainage systems, resource-rich basins and ecosystems sealed since the age of dinosaurs. And the world's most powerful nations are already maneuvering to control what happens when the ice no longer hides them. China is constructing a new year-round station in Marie Byrd Land set for completion in 2027. Russia is reopening and expanding bases just 11 miles away, while laying runways for heavy-lift aircraft. Antarctica is shielded by a treaty that bans mining and freezes territorial claims. But in 2048, that framework faces formal review. And when it does, presence becomes leverage. Knowledge becomes destiny. So what exactly is hidden under the ice that carries the power to ignite global tension? This is no empty wilderness. Recent breakthroughs from robotic explorers, satellite constellations, and record-breaking sediment drills have revealed a continent far more volatile and valuable than any surface image suggests. To see why superpowers are positioning themselves so aggressively, we have to go under the ice. But first, zoom out. Antarctica is the fifth largest continent on Earth, larger than Australia and Europe combined if you count the ice shelves. It holds 70% of the planet's fresh water in an ice sheet thick enough to bury the entire Himalayan range. It is the coldest, driest, windiest place on the planet. Temperatures plummet to minus 90 degrees Celsius. Winds exceed 200 miles per hour. In winter, entire regions vanish into months of polar night. And yet life persists from the surface, down through the ocean, and deep beneath the ice itself. So let's descend. Antarctica is a library written in frozen time. Snow falls year after year, compacts under its own weight, and seals tiny bubbles of ancient atmosphere between crystals. Each layer marks a season, a decade, a millennium. Scientists drill and extract long cylinders of this archive. The deeper the core, the farther back in time. In 2025, a multinational team pulled the longest sediment core ever recovered from beneath an active ice sheet. 228 meters of mud and rock, drilled through 523 meters of overlying ice at Crary Ice Rise. Initial analysis shows layers reaching back 23 million years, a time when global temperatures were several degrees warmer than today, and the West Antarctic ice sheet retreated dramatically, leaving open ocean where ice now stands. Shell fragments from light-dependent marine organisms confirm periods when the Ross ice shelf collapsed entirely. If it warms again, that record vanishes forever. This is how we read Earth's deep climate memory: carbon dioxide spikes, methane pulses, dust from distant deserts, volcanic markers. The ice remembers when forests grew where ice now reigns. This is still only the surface layer. Before we push deeper, notice what happens when wind scours the snow away. In certain zones, powerful katabatic gusts strip the top layers, exposing blue ice fields hundreds of thousands of years old. Compressed until every air bubble is squeezed out, the ice absorbs longer wavelengths and glows sapphire under the low sun. Elsewhere, snow keeps accumulating, burying everything beneath it. And then there is Mount Erebus, the southernmost active volcano on the planet. Volcanic gases carve warm caves into the ice, where scientists have discovered mosses, algae, and DNA sequences unmatched anywhere else on Earth. Life finds a way even inside steam-filled voids at the edge of the world. But the strangest surface feature is not alive. Blood falls on Taylor Glacier, bleeds crimson across the ice like an open wound. The water emerges clear, then turns red on contact with oxygen. It is ancient brine more than twice as salty as seawater, kept liquid at -5 degrees Celsius by its chemistry after millions of years, sealed under 400 meters of ice. Dissolved iron oxidizes on exposure. Similar outflows exist across the continent, most never reaching daylight. When they do reach the Southern Ocean, they deliver iron, carbon, and nutrients that trigger massive phytoplankton blooms. Everything downstream depends on that hidden delivery system. We are now 1,000 feet down. The ice here behaves in ways that shatter expectations. Most imagine Antarctica as a uniform slab, slowly melting from above. Reality is far more fractured. West Antarctica is thinning at accelerating rates. Glaciers surge toward the sea. Ice shelves fracture and collapse. In 2025, a robot named Icefin drifted for 8 months beneath Thwaites Glacier, mapping warm, salty pulses surging inland in focused jets that carve vertical melt chimneys through the ice. Melt rates inside those chimneys are several times higher than surrounding areas. The glacier's grounding line is retreating faster than models predicted because heat is attacking from below as well as above. Yet East Antarctica tells another story, colder, thicker, with snowfall still adding mass in places. The continent does not act as one. It is a patchwork of systems in tension, and that tension is rising. You are now more than a kilometer beneath the surface. Pressure is crushing. Between ice and bedrock, water moves in a continent-scale drainage network only recently mapped in full. In 2025, Cryosat-2 satellite data revealed 85 previously unknown active subglacial lakes, raising the total of known active lakes to 231 and the overall count to more than 760 when including inactive features. These lakes periodically drain and refill, sometimes releasing billions of liters in days. 5 major interconnected networks now documented show water, traveling hundreds of kilometers unseen. When lakes drain, the ice surface above drops by meters, then rebounds as pressure shifts. The entire ice sheet rides on this hidden plumbing. Human access to this world remains minuscule. Every drill site combined would fit inside a single city block. So we listen from above. Aircraft tow electromagnetic loops. Seismic arrays record echoes. We are mapping a hidden hydrology that lubricates the base and controls how fast the ice slides toward the ocean. Occasionally, this system announces itself. Bloodfalls is one window, but the real story is what never surfaces. Nutrient-laden water eventually reaches the Southern Ocean, fueling the base of a food web that supports krill swarms so vast they can be seen from space. Those krill sustain penguins, seals, and whales. Emperor penguins in particular face new pressures. Satellite monitoring in 2025 revealed that shrinking sea ice forces molting colonies into ever-tighter clusters on fast ice. When the ice breaks early, entire groups can be lost. The Southern Ocean is changing faster than any other marine ecosystem, and the hidden subglacial contribution to that change can no longer be ignored. Now pushed past 3.5 kilometers. The darkness is absolute. Pressure exceeds 400 atmospheres. Here lies Lake Vostok, 240 kilometers long, 50 kilometers wide, sealed for millions of years. It has never seen sunlight. Nearby, Mercer Subglacial Lake, sampled after drilling through more than 1,000 meters of ice, yielded microbial communities that survive purely on chemical energy from bedrock minerals. Similar life appears in Lake Whillans. These ecosystems have been isolated longer than modern humans have existed. They represent the closest analog we possess to the oceans beneath the ice shells of Europa and Enceladus. If life thrives here without photosynthesis, the possibilities for habitable worlds across the solar system expand dramatically. Antarctica is not hiding extraterrestrials, but it is teaching us what extraterrestrial life might require. And the deeper you go, the more heat you encounter. The bedrock is not a cold, inert floor. More than 200 candidate subglacial volcanoes have been identified through gravity and magnetic anomalies. Some are active. The weight of the ice prevents explosive eruptions, so heat melts cavities from below, creating pockets of water and steam that destabilize the ice above. Seismic records show ash layers from past eruptions preserved inside the ice sheet. Geothermal flux was underestimated in early models. It helps explain why West Antarctica is responding faster than expected to surface warming. The ice is being attacked from both directions. These volcanoes rest atop something far larger, the true continent. Using more than 60 years of radar, seismic, and now advanced ice flow perturbation analysis, scientists have produced BedMap 3, the most detailed subglacial topography ever assembled. When the ice is digitally stripped away, the familiar white plateau disappears. In its place rises a rugged landscape of buried mountain ranges sharper than the Alps, deep canyons plunging 3.5 kilometers below sea level, and thousands of previously unmapped hills and ridges. A newly revealed channel in the Maud subglacial basin runs nearly 400 kilometers long, 6 kilometers wide, and 50 meters deep on average. The Gamburtsev Mountains stand as tall as the European Alps, yet remain completely invisible. Denman Canyon is the deepest known land canyon on Earth. Ancient river valleys snake between highlands exactly as they did tens of millions of years ago when Antarctica was still part of Gondwana. East Antarctica is old, thick, stable crust. West Antarctica is a stretched, fractured rift zone where the crust thinned and sank, bringing heat closer to the surface and explaining the concentration of volcanoes. Much of West Antarctica lies below sea level. Remove the ice today, and it would fragment into islands. Fossil pollen and leaf impressions locked in the rock prove this land was once temperate forest with flowing rivers. The Wilkes Land gravity anomaly, a 300-kilometer-wide circular structure, remains debated. It may mark one of the largest impact craters on Earth, or a massive magmatic intrusion. Whatever its origin, it is enormous and still concealed. For millions of years, the ice has pressed the continent downward into the mantle. Remove that weight, and the land rebounds over centuries to millennia, reshaping coastlines, rerouting rivers, and altering stresses deep in the crust. This isostatic memory means the surface we see today is not the surface that will exist if the ice thins. The bedrock remembers a green Antarctica. The ice sheet does not. So why does any of this matter enough to drive nations to build stations in one of the harshest environments on the planet? Because the geology beneath the ice mirrors the resource-rich continents it once joined: South America, Africa, Australia, India. Sedimentary basins formed when Gondwana was whole carry the same potential for hydrocarbons and minerals, now locked under kilometers of ice. Geophysical surveys have already identified promising structures in the Weddell Sea region and the Dufek intrusion with signatures of platinum group elements and base metals. While no commercial deposits have been confirmed, exploration is effectively impossible today. The theoretical scale is staggering. Trillions in potential value if extraction ever becomes feasible. For now, the Madrid Protocol prohibits all mineral activity. But the protocol comes up for possible review in 2048, and the race to establish strategic presence is already underway. Russia has conducted extensive seismic work across large sectors, mapping potential resources in areas it has long eyed. China has expanded its Antarctic footprint faster than any other nation, placing stations in every claimed sector, plus the unclaimed Marie Byrd land zone. The new Cox Point station and the coordinated reopening of nearby Russian facilities signal deepening collaboration. The United States faces aging infrastructure and shifting budget priorities that risk ceding ground. Every new station, every runway, every research flight doubles as a claim on future influence. Scientific data collected today becomes negotiating power tomorrow. The subglacial lakes, the microbial worlds, the nutrient rivers, the geothermal engines, the ancient forests preserved in stone, all exist in a balance forged over tens of millions of years. A balance that is now tipping. Sea level projections grow more uncertain precisely because we are only beginning to quantify the hidden water systems and heat sources. If the West Antarctic ice sheet retreats, as it did 23 million years ago, global coastlines shift by meters, displacing hundreds of millions, and triggering resource and migration pressures that could dwarf current geopolitical strains. For more than 60 years, the Antarctic Treaty has kept the continent a zone of peace and science. In 2048, its core environmental protections can be revisited. Technology is advancing. Once impossible access is becoming imaginable. Some environments endure precisely because they have remained untouched. Antarctica is the ultimate example. Disrupt one layer and the effects cascade. Heat from below accelerates, melt from above, lakes drain faster, ice slides quicker, oceans warm, fisheries shift, nations compete harder for what remains. The hidden world under Antarctica does not belong to any flag. It belongs to the shared future of a warming planet. What we choose to explore, protect, or exploit in the decades ahead will test whether humanity can still cooperate at the extremes, or whether the last pristine frontier becomes the next arena of tension. If this journey through the ice has changed how you see the stakes beneath our feet, subscribe to follow every new revelation from the frontiers that will shape the century. Comment with your thoughts on what must happen before 2048 to keep the peace. Share this with anyone who still believes some places on Earth should remain above the fray. The ice remembers. The question is whether we will.